Hello students, welcome to our YouTube channel Physics for UG. So in this video we shall discuss about cooling due to adiabatic demagnetization. So first understand what is demagnetization. So first of all, there is a word magnetization in magnetic field. That means whenever a magnetic material is kept in a magnetic field, the substance get magnetized. That means the dipoles in this material, the dipoles or magnetic dipoles are aligned in the magnetic field. Suppose there is a material and this material has the magnetic dipoles arranged in a random direction when magnetic field B equal to 0. But when there is a magnetic field applied along from left to right, then what will happen? Then all the dipoles inside the metal are arranged in the field direction. That means they are aligned, and this process is called magnetization. So in simple word, अगर एक मटेरियल को हम मैग्नेटिक फील्ड में रखेंगे तो उसके बाद क्या होगा, उसका जो मैग्नेटिक डाइपोल्स वो अलाइन हो जाएंगे मैग्नेटिक फील्ड के डायरेक्शन में. तो इस अलाइनमेंट होना प्रोसेस को हम मैग्नेटाइजेशन बोलते हैं, और उसका जो रिवर्स पार्ट है उसको हम डीमैग्नेटाइजेशन बोलते हैं. मतलब हम सपोज मैग्नेटिक फील्ड को ले जाएंगे, मैग्नेटिक फील्ड जीरो कर देंगे तो क्या होगा. तो ये जो प्रोसेस होता है मैग्नेटिक फील्ड को रिड्यूस करने में, जो प्रोसेस होता है उसको हम डीमैग्नेटाइज बोलते हैं, और मैग्नेटिक फील्ड को इंक्रीज करने में जो प्रोसेस होता है उसको हम मैग्नेटाइजेशन बोलते हैं. सो व्हाट हैपेंस? सो इन दिस पार्ट वी विल डिस्कस कूलिंग ड्यू टू एडियाबैटिक डीमैग्नेटाइजेशन. दैट मीन्स एडियाबैटिक प्रोसेस में डीमैग्नेटाइज करने में क्या होता है, कूलिंग होता है. उसका ऑपोजिट क्या है, हीटिंग होता है. तो मैग्नेटाइज करने में हीटिंग होता है और डीमैग्नेटाइज करने में कूलिंग होता है. ओके, लेट्स अंडरस्टैंड. देयर आर मेनी मेथड्स इन कूलिंग ए मटेरियल और गेटिंग ए वेरी लो टेम्परेचर. There are many methods to attain very low temperature, such as boiling helium under normal pressure. This is one method, and in this method we can achieve temperature as low as 4.2 Kelvin. Up to 4.2 Kelvin we can get the temperature. And another process is liquid helium under reduced pressure, and in this process we can get temperature up to 1 Kelvin or even less. लिक्विड हीलियम अंडर रिड्यूस्ड प्रेशर प्रोसेस में हमको एक से भी कम टेम्परेचर हमको मिल पाएगा. ओके, एंड कूलिंग बाय एडियाबैटिक डीमैग्नेटाइजेशन ऑफ पैरामैग्नेटिक सॉल्ट्स. दैट मीन्स बाय यूजिंग पैरामैग्नेटिक मटेरियल्स वी कैन गेट कूलिंग बाय यूजिंग द प्रोसेस एडियाबैटिक डीमैग्नेटाइजेशन. ओके, सो हाउ टू प्रोसेस इन दैट method. Okay, first of all let me give you two definitions. First is heating effect, and that is the cooling effect. How heating effect is observed? Remember, when the process is adiabatic magnetization, magnetic field को बढ़ाना है इन adiabatic situation में, तो उसको heating effect बोलते हैं. और adiabatic process में जो प्रोसेस मैग्नेटिक फील्ड को डिक्रीज होता है, मैग्नेटिक फील्ड को डिक्रीज हो जाता है, तो इसमें डीमैग्नेटाइजेशन प्रोसेस होता है. तो इसमें हमको कूलिंग इफेक्ट मिलता है. इन दोनों को, हीटिंग इफेक्ट एंड कूलिंग इफेक्ट, इन दोनों को हम थर्मोमैग्नेटिक इफेक्ट बोलते हैं. ओके, नाउ लेट्स अंडरस्टैंड द थर्मोडायनामिक एक्सप्लेनेशन ऑफ दिस प्रोसेस. ओके, at a very low temperature, this is one assumption, at very low temperature all molecules are in solid form, so volume does not change. So at a very low temperature, similar to ice, very low temperature, because water becomes ice at very low temperature, 0 degree Celsius. So in the, at very low temperature all materials are in solid form. Okay, that means temperature low होगा तो material solid हो जाएगा. That is dV equal to 0. Volume does not change. that is volume does not change that remarkable quantity, so dv will be equal to 0. What is dw? Should dw equal to pdv minus bdm, which is equal to minus bdm. What is dw? So in case of magnetic field, we have studied the magnetic work. The magnetic work dw equal to minus bdm. So the mechanical work in thermodynamics is the pdv. So total work done dw equal to pdv minus bdm. So the remaining part only minus bdm, क्योंकि dv जीरो हो जाएगा, जीरो होता है, इसमें वॉल्यूम चेंज नहीं होता है, सो dv जीरो होता है, इसीलिए dw इक्वल टू माइनस bdm होता है. If we compare with dw, that is our original equation, dw equal to pdv and dw equal to minus bdm. If we compare these two equations, then minus b plays as the same role as p, pressure, and m plays the same role as volume b. So p as the same as minus b and that of v is same as m. इन दोनों सेम रोल प्ले करते हैं. प्रेशर प्ले करता है माइनस बी का रोल एंड वॉल्यूम प्ले करता है मैग्नेटाइजेशन का रोल. ओके, नाउ देयर इज ए मैक्सवेल रिलेशन del t by del p at s equal to del v by del s at p. This is the fourth Maxwell relation in thermodynamics. We use this formula. Start this one. Okay, minus del t by del v at constant s equal to del m by del s at constant b. How it happens? Remember, put pressure as minus b and volume as m. Pressure as minus b and volume as m. So we get this one, pressure minus b, so minus this one is minus b and del m by del s, del m by del s, and this is s, and this pressure as you have to put b. That pressure is constant, so minus b is constant, means b is constant. There is no need to write negative sign here. Okay, so what will happen? Next part, del t by del v at constant s equal to minus del m by del s at constant b. Just introduce a minus sign. Okay, next is minus del m by del t, b at constant b and del t by del s at constant b, and this part is modified. We differentiate del m with respect to delta t and then delta t with respect to delta s. That is by using chain rule. Okay, so what is del m by del t and what is del t by del s at constant b? Remember, cb is equal to t delta s by delta t at constant b, similar to Ship equation, similar to CV equation, similar to that is specific heat at constant magnetic field. Cb equal to T delta S by delta T at constant B. So what is delta T by delta S at constant B? Delta T by delta S at constant B will be equal to T by Cb, because delta T by delta S उसको रिवर्स कर दिया जाएगा तो T by Cb रहेगा, T by Cb होगा, T by Cb. तो put this value here, T by Cb. So this will be T by Cb. Negative sign is there, T by Cb, del M by delta at constant B. So what is dt? Dt equal to dt. Look at from this part is there. If you keep dt here, then this db part will be multiplied in the right side part. Okay, dt equal to minus t by cb del m by del t at constant b dp. This is equation 1. This is the rate of change of temperature with b. That means dt is the change in temperature with dp. This means magnetic field. Okay, next we have to our target is to find the cooling effect. How this process, how magnetization, diamagnetic material, how paramagnetic material produces cooling effect in adiabatic demagnetization. Okay, So for a paramagnetic material, the Curie's law. This is Curie's law. What is Curie's law? Curie's law is for paramagnetic materials. That means the magnetic susceptibility is inversely proportional to temperature. That is Curie's law. And chi m equal to k by t. K is the constant. And what is chi m? Chi m the magnetic susceptibility, that is equal to m by b. That is m by b. M is the magnetization and b is the magnetic field induction. That is k by t. And m equal to kb by t. M equal to kb by t. So del m by del t are constant b. Del m by del t constant b equal to minus kb by t square. Differentiating this m with respect to t, kb is constant and the derivative of 1 by t equal to minus 1 by t square. So del m by del t constant b equal to minus kb by t square. So using equation 1, that equation was the variation of temperature with magnetic field. So using this line equation 1, dt equal to minus t by cb into minus kb by t square into db. That is minus kb by cbt into db. Very simple expression. Minus plus t by cb kb by t square cb. Remember, this cb is not c into b, that is specific heat at constant magnetic field, c subscript b. Okay, that is equal to kb by cbt. 1t cancel, kb by cbt into db. Now this is dt. Now we have to integrate. Now integrating the above from Ti to Tf. Ti मतलब initial temperature and Tf मतलब final temperature. Initial temperature, final temperature. And that of B to O. B is the magnetic field and 0 is the zero magnetic field. Why B to 0? Because I have already mentioned that this process is a demagnetization process. तो in demagnetization process में क्या होता है? तो magnetic field फाइनाइट वैल्यू से डिक्रीज होकर 0 होता है एंड इन मैग्नेटाइजेशन प्रोसेस मैग्नेटिक फील्ड 0 से बढ़कर कुछ फाइनाइट वैल्यू होता है. तो दिस वन इज द मैग्नेटाइजेशन एंड दिस वन इज द डीमैग्नेटाइजेशन. सो फ्रॉम बी टू 0, that means we use a demagnetisation process because our target is demagnetisation process. That's why Ti to Tf. Okay, indicating. So what will happen? This equation, look at this equation, dt equal to kb by cbt. So take this t to the left side. So the equation will be t dt equal to kb by cb dp. Kb by cb into dp. Integrating both sides with proper limits. So integrating the left side part from Ti to Tf, initial temperature to final temperature, and the right side part from B to 0. So integration of t dt equal to t square by 2 from limit Ti to Tf and k by cb. Integration from b db equal to b square by 2 from b to 0. Put the upper limit value. In the left side part, that will be tf square minus ty square. In the right side part, that is put 0 first in place of b, that is 0 minus this much. So automatically that part will be negative. There will be negative sign, minus kb square by 2cb. This is the expression half tf square minus ty square equal to minus kb square by 2cb. So what is tf square? So tf square equal to ty square minus kb square 2cb. Remember, look at this line, this equation. In the right side part, there is negative sign. Okay. In the left side part, tf square minus ty square. When the right side part negative, then the first part will be less and the second part will be more. Less minus more equal to negative, but more minus less will be positive. So hence, the Ti will be more and Tf will be less. So Ti square is more than Tf square. What is Ti? Initial temperature. What is Tf? Final temperature. So final temperature is less than the initial temperature. The final temperature is less than the initial temperature. That means in this process, cooling is produced. That means cooling is produced in this process. Why cooling? Because initial temperature is more than final temperature. Suppose initially the temperature was 30 degrees Celsius and finally the temperature became suppose 20 Celsius. Then this is initial Ti and this is final. So Tf is less. So Tf is less than Ti. So this effect is the cooling effect. So in this process we used a paramagnetic material. That means by using a paramagnetic material we used the adiabatic demagnetization process to achieve the cooling effect. Anyway, this will help you in different applications. This is applications. Thank you. If you like this video, share and subscribe the channel. Thank you.